Welcome to the Simons Foundation Presents webinar. My name is Chiara Mingarelli, and I'm a professor of physics at the University of Connecticut and an associate research scientist at the Flatiron Institute's Center for Computational Astrophysics. So today, I just want to give you a quick review of how the webinar works because it's interactive, which is going to be really exciting. Paul is going to give us a virtual tour of the solar system. If you have any questions, please enter them into the Q&A at any point during the talk. Halfway through the talk, I'm going to be taking some of your questions that have either come up again or that are particularly awesome, and we'll ask those questions to Paul. At the end of the talk, we're going to wrap up with a trivia game. So before we get started, it's my pleasure to introduce you to Paul Sutter. And so Paul is a serious scholar as well as being an avid science communicator. He received his PhD in 2011 from the University of Illinois at Urbana-Champaign. He held postdoctoral positions in Italy and France before joining the faculty at Stony Brook as a research professor last year. We're delighted that Paul's also a guest researcher at the Flatiron Institute in the Center for Computational Astrophysics. So I met Paul at Caveat, which is a science improv comedy club, and we were doing a show called Astronaut Training Live, and we were competing for a trip to Mars. Chatting with Paul was really fun. He told me that he was in New York and he was on a book tour where he was promoting Your Place in the Universe, and that was published in November 2018. And his next book, How to Die in Space, will be published on June 2nd this year, 2020. So in addition to this, Paul also hosts the popular Ask a Spaceman podcast and YouTube series, and his contact details will follow after this talk. So without further ado, I present to you Paul Sutter. Take it away, Paul.
All right. Thank you so much, Chiara. And hello to everyone tuning in live from around the world. Like Chiara said, this is going to be super interactive. I am going to tour through the solar system with you, but I want your questions. So start filtering them to the Q&A right now, and Chiara will collect them. And then we'll take frequent breaks to answer your questions about anything in the universe. I mean, anything spacey in astronomy. I'm not going to help you with any personal issues that may have developed as you're living with your friends and relatives 24/7. Now, also at the end of this presentation, we're going to chat for like an hour. And at the end of it, we are going to do a trivia game. So make sure you go to slido.com, that's SLIDO.com, and use the hashtag Sutter, that's capital SUTTER, and then that will get you on the game so that you can compete. There will be no prizes awarded except for knowledge. Now, without further ado, let me share my screen because I have some pretty cool software running. This is a software program called Celestia that you can get for free. You can download this for free on your own computer and fly around the universe. And right now, you should be seeing a very familiar sight. This is home. This is planet Earth. And sometimes there's good days on planet Earth. There's warm days on the beach with pina coladas. And sometimes there's bad days like, I don't know, global pandemics that keep us all locked inside. So you might be wondering, with this whole planet, sure, there's a lot of room, but maybe we can pick somewhere else to go. After all, everything you know and love, every bit of life, every bit of air you breathe, every drink of water lives within a thin 60-mile band of the surface. If you were to inflate an egg to be the size of the planet Earth, the atmosphere, the place where every bit of life lives on the Earth, is thinner than that shell of the egg. So space is not very far away. If you could drive a car 60 miles an hour, but straight up, we'll get in space in less than an hour. So it feels like a big place. Earth feels great. Earth feels like there's a lot of room, but we are right here against the edge of space. So there's a lot of people, there's a lot of problems. Maybe we can go somewhere else. I hear a lot of talk about Mars, right? Let's go to Mars. Let's make a Mars colony and let's put some people on Mars. Okay, take some of the pressure off of the Earth. So we're going to make the hop over to Mars. And now Mars, if we were doing this in real time, I'm about to shoot us over to Mars. If we were doing this in real time, it would take about 6 months using our current technology to make the hop to Mars. 6 months. This webinar is going to be a little bit shorter than 6 months long. So I'm going to speed up time here and we're just going to blast off. You want to count down with me? 3, 2, 1, go. Here we go, all the way to Mars, making the journey in a matter of seconds. And then stopping right at the end, right before we crash into the planet. That is a very handy feature of this software. So check this out. Mars, Earth's twin. We can orbit around it. We can see some of the cool features here. Check this out. You see that long, snaky thing right there? Right in the middle, crossing through us. I'll zoom in just a tiny, tiny bit. That is the Valles Marineris, which is not a dipping sauce. It's the Mariner Valley. It is the largest canyon in the solar system. If you were to put this canyon in the Earth, it would dwarf the Grand Canyon. It'd make the Grand Canyon be just the puny canyon. The Valles Marineris would stretch from one end of the United States to the other. That's Mars. This is Mars. So there's cool stuff on Mars, right? Check this out. If we fly over to the North Pole, look at that. Look at that. There's some ice caps on the North Pole. And there's a little tiny ice cap on the South Pole too. Check it out. Go all the way. There it is. There it is. Tiny little guy right there. So there's cool stuff on Mars. There's the biggest mountain in the solar system, Olympus Mons. There it is. That is not it. Sorry, I was about to point to it, but that is not Olympus Mons. I'll wait for it to swing into view. It has the biggest mountain in the solar system, the biggest canyon. Pretty cool place, right? I mean, yeah, it's a literally cool place. So the hottest it gets on Mars is around 95 degrees Fahrenheit, which is pretty warm. Okay, last time I checked, 95 is pretty warm. The coldest it gets on Mars is negative 225. Negative 225. Average temperatures are well below zero, usually hanging out around negative 50 to negative 100 degrees Fahrenheit. That's on average. We are so far out from the sun here at Mars that it only gets about 60% of the sunlight that we do on the Earth. Why do people want to go to Mars? I don't know. You're going to have to ask them. I'm not the biggest fan of Mars. It's cold all the time. It is red all the time. And all that redness is from Martian dirt, iron that got oxidized. This whole planet is rusted. It's literally a rusted planet. That's why it looks so red. I don't know. It's a little garish for my taste. I prefer more neutral colors, earth tones, if you will. But Mars, a lot of people want to go there. A lot of people want to build colonies there, explore it. I guess I'll let them. But here's another thing about Mars, folks. There is a tiny little bit of atmosphere, and you can see the edges of the atmosphere right here at the edge of this planet. Yes, it technically has an atmosphere. The atmospheric pressure on Mars is less than 1% of the air pressure on the Earth. So you can't breathe it. That's basically vacuum, okay? If you stepped outside of your front porch on Mars and took a deep breath, you would just die, all right? Because there's nothing to take a deep breath of. And even if you could breathe it, that air is pure, almost pure carbon dioxide, which if you're a plant is great news, but if you're anything else, is horrible news. So that's it. That's Mars for us. That is the 4th planet from the sun. I suspect we will eventually get explorers on Mars, leaving footprints and doing science experiments and then coming back to Earth. A total round trip mission time from Earth to Mars and then back, which is the important part, is about 2 years. And that's because we have to wait for the orbits to line up just right to send a mission to Mars, and then they have to wait for the orbits to line up again to get the mission back to Earth. So all told, any mission to Mars is going to be around 2 years long, which is one of the reasons it's so insanely difficult to get missions to Mars, because it's really, 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 really stinking far away. If that wasn't enough, every once in a while, Mars suffers global dust storms. All right. And I'm not joking, a dust storm that completely engulfs the entire planet for months on end. This is what knocked out one of our rovers that depended on solar power. It's kind of hard to see the sun when you're living in a planet-wide dust storm. But if you'd like to go to Mars to escape coronavirus or just try something new in your life, I am not going to stop you, because I'm just going to stay right here on Earth. But okay, so maybe Mars isn't the best place for a colony. What are some other candidates? Every once in a while I hear Venus. So we're going to scoot on over to Venus. And once again, in real life, this journey would take many, many, many months, but with the power of a pretend computer program, we can get there in a matter of seconds. Here's Venus, the 2nd planet from the sun. It's about the same size as the Earth. It's called the sister planet of the Earth because, we're roughly the same size. Here's something that this software program doesn't really get across. If you were this close to Venus in real life, these clouds on Venus are so bright and so reflective, and Venus is so close to the sun that you would literally be blinded. It is too bright to look at this distance. You have to go way out. Like you have to be like, I don't know, like here before Venus is comfortable to look at. And even then it'd be an angry point of light. It wouldn't be all that fun. But if you're in orbit where you can actually pick out some details on the cloud tops, you're just going to be straight up blinded. So if you decide to go to Venus, pack plenty of sunglasses, especially when you're in orbit. In orbit, unfortunately, is pretty much the only place you're going to be. The reason is, oh my gosh, Venus, I feel bad for Venus, actually. I feel bad for Venus because it had a good chance. It had a lot of opportunity. It was right there. It used to be in the habitable zone of the sun, which is the region around our sun that can support liquid water. It's not too close where all the water evaporates, and it's not too far where all the water freezes. It was right there. And in fact, billions of years ago, Venus looked nothing like this. Billions of years ago, Venus had oceans and rivers and streams and white fluffy clouds. It looked gorgeous. It looked like the Earth. But as the sun ages, as our sun gets older, it steadily gets brighter with time. And about 2 to 3 billion years ago, it got too hot for poor old Venus. The oceans on the surface of Venus began to evaporate because that's what water does when it gets hot. The water went out into the atmosphere and it acted as a greenhouse gas. It heated up the planet. Now that the planet was a little bit hotter than before, more ocean water evaporated, put more water vapor in the atmosphere, heated up the oceans, put more water in the atmosphere, boom, 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 boom. Before you know it, all of Venus's oceans have evaporated. Without those oceans, plate tectonics, the great motions of the continents, ground to a halt. And then carbon dioxide just started oozing out of the ground and poisoning the atmosphere. Venus's atmosphere is one of the thickest in the solar system. It is the thickest around any of the rocky planets. The air pressure on the surface is 92 times the air pressure as on the surface of the Earth. 92 times. And that atmosphere is almost pure carbon dioxide. But wait, there's more. Not only is this atmosphere chokingly thick and horrendous and poisonous and awful, it also has a lot of sulfuric acid, aka acid rain. So here we are, Venus, a thick choking atmosphere that is constantly nonstop raining acid rain. How bad is it on Venus? Glad you asked. Venus is the second planet from the sun. We'll visit Mercury, which is a little bit closer in. It is so hot on Venus. The temperatures average around 850 degrees Fahrenheit. 850 degrees Fahrenheit. Folks, that is hot enough to melt lead. If you were to take a lead bar, a solid lead bar, and put it on the surface of Venus, and then turn around and look back, when you looked back, you would just have a puddle of lead, like an ice cube melting on the sidewalk on a hot July day. A bar of lead will do the same thing on Venus. There have been very, very few missions to Venus, obviously, because, it's kind of lame. But there have been some Russian probes that made it to the surface and lasted all of like 20 minutes before being crushed like a soda can. If you want to go to Venus, fine. There are some places in the outer atmosphere. There's a certain height in the atmosphere. And I'll zoom in just so you can see more of this atmosphere. There's some feature, or there's a place, a height, an altitude in the atmosphere where the temperatures and pressures are kind of sort of Earth-like, like it's not actually horrible, except for the atmosphere being made of carbon dioxide and sulfuric acid. So if you can take care of that and you can build like Star Wars style floating cities, you're golden, but good luck getting that to work. That's just, I'm not even going to help you with that homework problem, okay? As tempting as it looks, as bright as Venus looks, I don't think it's going to be a home for us. So what do we got next? Might as well move closer in. If Venus is terrible, Mercury is going to be worse. So we're going to slide on over to Mercury, the closest planet to the sun. There she is. And you'll notice something different about Mercury that you may have seen on Venus and Earth and Mars. Those other three planets had nice, lovely atmospheres, right? They had thick layers or thin layers, but at least they had something. Mercury is dead and barren. I mean, just look at it as we orbit around it. I'll just let it orbit here so you can see some of the features. There's no air here. There's no water. There's no ice. There's no fun. If you're a fan of craters, Mercury has a lot of them. Look at all those pockmarks up and down the surface and all these impact sites from asteroids and comets striking this planet over the course of billions of years. This is not a friendly place to live. And Mercury has so many craters like this because it has no air. There's nothing to erase them. There's nothing to weather away the craters. If something hits Mercury and just hits it, carves out a big hole, there's no wind or water to ease the bruise. It just sticks with it. And so that's why we see all these nasty, nasty features on the surface. Speaking of the surface, we are very, very close to the sun. This is the closest planet to the sun. So there we see, look how big the sun is. Here, I got to chase it a little bit in the software. Look how big the sun is at Mercury than it is compared to the Earth. And wait till we get to the outer solar system, and you'll see just how tiny the sun can really be. That means because there's no air or water, and Mercury is so close to the sun, that the side of Mercury that happens to be facing the sun at any one moment reaches a scorching hot 800 degrees Fahrenheit. I mean, you're just sitting there, you're just getting blasted by the sun, like straight at you. But if you're on the night side, if you're down here on the back end of Mercury, because there's no air or water to transport that heat, it is frozen. It is negative 315 degrees Fahrenheit. So right there, that terminator line between the day side and the night side, that's a temperature difference of over 1,000 degrees, purely because of the sun. So if you want to live on Mercury, what are your choices? You're going to do day side, where you're going to get blasted at 800 degrees Fahrenheit, or night side, where you might as well just be in the furthest reaches of interstellar space for all the warmth you're getting. And because Mercury does rotate, it has a very slow rotation, but it does rotate. It's just not going to be fun. So I think that we've hit the 3 inner rocky worlds. Kiara, do we have any questions popping up on the chat yet? I feel like it's a good time for me to drink from my NASA mug and hear a question.
We do. We have a few good questions. We're going to start with Lisa LaBelle's question. So she wanted some additional clarification on why we have to wait for the orbits of Earth and Mars to line up before launching a mission.
Good question, Lisa. Let me head back over to Mars. Bye-bye, Mercury. We didn't like you anyway. It's going to be a longer trek here. There we are. Whoa, time's going super fast here. Let's slow it down. That's a great question. So it takes some time to travel from Earth to Mars. If Earth and Mars are on opposite sides of the solar system when you launch, then you have to travel 180 million miles to make it over to Mars. So you want to wait for Mars to be on the same side of the solar system as the Earth, so you make that hop in as short a distance as possible. But then now that you've landed on Mars, Mars has moved on in its orbit, and so has the Earth. So if you were to just pick up and turn around and leave again, by the time you left, Earth would be on the opposite side of the solar system. So you have to wait again for all the orbits to line up so you can be close again. Orbital trajectories and dynamics is tricky business. That's why we leave it up to the professionals. You got another question for me, Kiara?
I do, thanks. That's a great answer. The next question is from Gwyneth Hauser. If Venus used to have so much water, could it or did it support life at any point?
Ooh, this is such a fun question. I love questions like this. Yeah, here's the thing. We're pretty sure. I mean, we don't know for sure, but we're pretty sure, which is good enough, that 3 billion years ago or so, Venus had liquid water. 3 billion years ago, Earth had liquid water. 3 billion years ago, Earth had liquid water and life. Fill in the blanks. Did 3 billion years ago Venus have liquid water and life? Totally open question. For sure, there ain't no life on Venus right now. Good luck in that suit. But 3 billion years ago, before things went a little bit haywire, who knows? This is something I didn't mention about Mars. 3 billion years ago, Mars had liquid water and an atmosphere and oceans and the whole deal. Does Mars have life today? Probably not. We're interested. It's not entirely ruled out. Certainly has a better chance than Venus. But did Mars have life 3 billion years ago? We honestly don't know. We do not know how unique the Earth is when it comes to generating life. Maybe we're the only ones anyway. Maybe 3 billion years ago, there were 3 planets in orbit around the sun, all hosting life. That is a great question. Feel free to write up a research paper because we got no idea. Let's do one more question, Chiara.
Okay, I really like this question from Mark Innocenti. Could we live at a strategic pole location on Mercury?
Great question. Let's fly over to Mercury to show you what he's talking about. So yeah, if you just pick one spot on the surface, you're going to end up in daylight and then night side and then day side, and you're going to get cooked. But let's see if we do this right. If we look at that, If you picked a spot like right there, then you might be always in twilight, like half illuminated and half in darkness, and it just might have the right mix of temperatures. Fine, I guess you can do that. It's still going to be Mercury. There's still no air. There's still no water. There's still nothing interesting going on. I mean, I'm not trying to dog Mercury. Mercury is a great planet, but there might be more interesting places to live. But yes, you could possibly do it by building your colony like right there, right on the edge of that terminator and letting the planet spin around you. You can give it a shot. That's all you, Mark. That's all you. All right. So continuing on, those were the inner rocky worlds of the solar system: Mercury, Venus, Earth, and Mars. It seems like those other 3 planets aren't the best. Maybe there's something cool going on with Jupiter. So we're going to take the trek out. Now we're talking about the outer solar system. Jupiter is, going fast. So I'm going to slow down time here. Look at that. Gorgeous looking Jupiter in all her glory, all those banded clouds, all those formations. And look, coming right into view. Let me pause time so I can zoom in. The great red spot. You guys see that? Isn't that so cool? I love the great red spot. One of my favorite features in the solar system. This is a storm. This right here, to give you some sense of what's going on with Jupiter here. The great red spot is a hurricane. Just like we have hurricanes on Earth, it's a hurricane that has been blowing for at least 400 years. Right? It could have been blowing for longer, but before that, we didn't have telescopes to be able to see it. And this hurricane right here, to give you a sense of scale, you could fit 2 Earths side by side into this hurricane that's been blowing for over 400 years. Typical wind speed on Jupiter is nearing 400 miles an hour. Imagine, when those Weather Channel folks go out in the storm and they're like, I'm reporting live from hurricane. Yeah, imagine them trying that here. All right, they would just be incinerated. Horrible tragedy, but okay, it's going to be fun to watch. That's all I'll say. So Jupiter, this is the largest planet in the solar system by far. Jupiter outweighs the combined mass of all the other planets 2.5 times. So that means you can get rid of all the other planets in the solar system except for Jupiter, and you basically still have a solar system. We're just a rounding error when it comes to adding up all the stuff in the solar system. Jupiter's cool. fun to look at for sure. Also home to one of the most extreme radiation environments in the solar system. It has this gigantic, super powerful magnetic field that traps high energy particles. We do have a satellite in orbit around Jupiter right now, the Juno probe. It's only going to last a few years because all the radiation is just going to poison it. So, you know, I would say Jupiter's good for a nice quick look-see, but not a permanent visit. So maybe let's go further out. Maybe let's go further out. Who wants to go to Saturn? I do. And I'm driving. So I get to go. Here we go. Ah, yeah. Who doesn't love Saturn? If you ever get the chance to look at Saturn through a telescope, you absolutely should, because you will see the rings. You will see the gap in the rings. If you have a powerful enough telescope, you will see this thin gap here in the rings called the Cassini Division. You'll get to see it. It's amazing. It looks fake. I swear, it looks fake in a telescope. That's just how impressive it is. You can see on Saturn, there are these cloud systems, these streaks. It's like Jupiter, but not as much. This pale yellow color. These rings, though, are what capture everyone's attention. Look how thin these things are. Look at that, look at that, look at that. Wow. Razor thin. I'm not joking about razor thin. These rings are thinner than the building you're in right now. Top floor to bottom floor to top floor. These rings are thinner than the building you're in, but they extend for thousands of miles in width. And what they're made of is a collection of tiny, tiny bits of ice. Pure water ice, like more pure than the ice cubes in your drink right now. This is the water ice in orbit around Saturn. Trillions of pieces, all broken apart, pure ice, incredibly highly reflective. How did Saturn get its rings? We don't know. We've got some ideas, but it is a puzzle how Saturn sports such impressive rings. Again, Saturn, very, very pretty to look at. Remember, give you a sense of how far away we are from the sun right now. Look at this. Remember Mercury, how big the sun looked in the sky? Look at that. Look at that. There's the sun. There's the sun compared to Mercury. We are in the depths of the outer solar system here. It's really, really hard to get across just how big space is. I feel like these kinds of software systems help, because even traveling at the speed of light, it would take a few hours to travel from this Saturn to the sun. So we couldn't even do it in this webinar, traveling at the speed of light. There's one more thing I want to point out about Saturn. And if you want to live here, you can't live on the gas giant itself, obviously. But there's a bunch of moons, as the most moons of any known moons of any planet, over 80 moons. You can pick a home there if you want. It's going to be a little bit chilly. But do you see this? This is the North Pole of Saturn. Look at that. 1, 2, 3, 4, 5, 6. There's a hexagon right there on the North Pole of Saturn. This is a giant hurricane, a permanent hurricane, a polar vortex that's shaped by some storms in more southerly latitudes to give it the shape of this hexagon. It's one of my favorite things in the solar system. Just random, like, oh, by the way, yeah, there's this, geometric object on the top of one of our planets. No big deal. If you want to move to Saturn, it's going to take you a while to get there. It's going to take years. We had a mission there, the Cassini mission, that was in orbit around Saturn for 17 years. Delivered so much data. We're still trying to understand about the dynamics of the atmosphere and how these storm systems, the relationship between all these moons and the rings. So, I will give you this. If you were to say live, let's say on Enceladus, Then let me fly. Enceladus is one of the moons of Saturn. We'll go over to it. You could live here. You could live here. Look, there's plenty of, this is all water ice, by the way. And Saturn's around. Look at that view. Look at that. Who wouldn't want that in your sky every night? That's not so bad, okay? I'd actually pick this over Mars, but that's just personal. That's just personal. Anyway, let's keep going, folks. Let's go to everyone's favorite planet. That's right. We're headed straight for Uranus. Boom. There's Uranus filling up our screens. That's right. Uranus is cold and gassy. I don't know why Uranus is so cold and so gassy, but that's just the way it is. Something tragic happened to Uranus a long time. Sorry. I'm just cracking myself up, but I'm gonna lean into this joke. Something happened to Uranus a long time ago. It got knocked over. That's right. Uranus is tipped over. Look, see all these moons orbiting Uranus? There's the sun way over there, far away. I told you it was cold on Uranus. But look at the orbit of these moons, right? It's perpendicular to the rest of the solar system. This right here, facing the sun, when I scooch over here, this is the North Pole of Uranus. It's pointed right at the sun. It's getting too hot. And then this is the South Pole of Uranus over here in permanent shadow. We don't know what happened to Uranus a long time ago, but something very, very, very nasty happened to it to make it permanently tipped over like this. There are some good things about Uranus. It is the coldest place in the solar system, has a temperature of, or coldest planet in the solar system, I should say. Even though it's not the furthest planet out, it is the coldest. We're not exactly sure why. There is this whole tipped over thing, which probably tells us something interesting happened in the early days of the solar system. There's a lot of ammonia, there's a lot of methane, there's a lot of water, there's a lot of things going on in Uranus. So there's some good parts. Bad parts, it's called Uranus. All right, do you really want to live there? You want that on your driver's license? I mean, imagine if I opened up this webinar saying, hello, my name is Paul, a man from Uranus. You would shut it off immediately. Or you text all your friends to tune in right away. I don't know, but either way, you don't want that. Nobody wants to live here. Nobody wants to live here. I'm sorry, okay? I wish I could go back in time 200 years ago to when it was first discovered and say, guys, I know there's this whole Greek mythology thing and like Jupiter, Saturn, like, can we pick something else? Can we just go with Steve? Okay. Planet C, but I'm not in charge of naming things, much to my chagrin. Last of the giant planets, let's go over to Neptune. And really the last of the planets in the solar system. Yes, I know there's Pluto. Okay. We'll get to Pluto, don't worry. But here it is. Check this out. Look how beautiful Neptune is. Uranus's atmosphere is very bland. It's very bland. There are hardly any features in it at all. But Jupiter has great, interesting storm systems, and so does Neptune. There are these white clouds, and then there are these dark storms that appear in the atmosphere of Neptune. We are really far away from the sun here. We are 30 times further away from the sun than the Earth is. Look at that. Look at that. Even on the day side of Neptune, it's basically permanent twilight. It does not get bright out here. This is, there's a few definitions of what you could call the boundary of the solar system. This is the last major planet. All the other objects out here are dominated by the gravity of Neptune. The orbit here of Neptune takes 164 Earth years. Sorry, just one loop around the sun. That's longer than any of us have been alive. Neptune hasn't even made it around the sun once. There are some cool things happening inside of Neptune. Let's switch over to the day side so you get a better look. We suspect there's diamond rain. I'm not joking. There's diamond rain. There's carbon in the atmosphere, right? And the carbon can coalesce because of the extreme pressures and heat deep in the atmosphere. These planets, these giant planets, are cold on the outside but hot on the inside. But they can compress, and when you squeeze carbon together, you get diamonds. Then you get hard diamonds falling down to where it gets too hot, and then they melt and evaporate, and then the low carbon atoms swim back up to the top and then recombine, exactly like a water cycle on the Earth, but with temperature differences of hundreds of degrees and with carbon instead of H2O. That's it. Seriously, diamond rain in the atmosphere of Neptune. I'm going to take another break before I go to Pluto. Kiara, what are some questions we're getting? And if you have any more opportunities for Uranus jokes, let's do
it. There were quite a few of those. Well done. There are quite a few interesting questions, and I'm going to start off with a mashup between Zoe Brown and Aaron Waters' questions. And that's, can we land on Jupiter or any of the gas giants?
Ooh, super fun question. Let's go back to Jupiter because it's such a lovely sight. And it's actually super far away from Neptune. Gotta go past the sun. There's Jupiter. So yes, you could, if you wanted to, plant yourself. Oh, look, the shadow of a moon. The shadow of one of the moons right there. That's so cool. You could drop yourself off on the topmost layer of Jupiter. It's going to be pretty cold. It's going to be around negative 200 degrees Fahrenheit. The winds are going to blast you at a few hundred miles per hour. But, you could descend. Deep in the core of Jupiter, we suspect there is a rocky thing. We suspect there is a rocky core to Jupiter about the mass of 5 Earths. So there's 5 Earths sitting of rock, we think, sitting deep within the core of Jupiter. But to get there, you have to go through a lot of atmosphere. After a descent of just 10 to 20 miles, you're already experiencing, you're still in air, you're still in atmosphere, but you are experiencing air pressures greater than the deepest depths of the Earth's ocean. And eventually you reach a point where the temperatures become a little bit too hot. We're talking 45,000 degrees Fahrenheit. So that's right. At the cloud tops, you're at negative 200 degrees. And as you descend, by the time you're about 100 to 200 miles in, you're already at temperatures of 10,000 degrees. So yes, you can put yourself in the atmosphere of Jupiter, but don't you dare try to get any lower. It's just going to be bad news.
Okay, great. Thank you. So the next question is from Luan Casey. Do Saturn's rings spin at the same rate as the planet?
Ooh, this is such a fun question. Let me speed over to Saturn. And the answer is no, they don't. And in fact, not all bits of the rings rotate at the same speed. This isn't a disk. It's not like a frisbee with a hole cut out that's rotating around Jupiter. It is trillions of individual bits of rock, and each one of them are going at a slightly different speed. So yes, sometimes they crash into each other and merge. Sometimes they spread apart. Sometimes gaps open up and then disappear. These rings are not orbiting at the same speed or spinning at the same speed as the atmosphere of Jupiter or as the moons. They're their own thing. Fun question. What's next?
Okay, Tim Kessler would like to know, since we know Saturn's rings are made of ice, do we know if there's water on the planet?
Ooh, very, very cool question. So once you get past the asteroid belt in our solar system, there is water everywhere. In fact, water is the most common molecule in the entire universe. Think of what water is. Water is hydrogen and oxygen. Hydrogen was made in the Big Bang in the first 10, 15 minutes of the existence of the universe, is the most common element out there. And then oxygen is made in the cores of stars like our sun. Stars like our sun are pretty dang common. So you get a lot of oxygen and you'll get a lot of hydrogen. It is the most common molecule in the universe. So it is most commonly frozen. Earth is very special because we actually have liquid water. There's very, very few places in the universe with liquid water, but there is frozen water here in the rings of Saturn. And yes, we do know for sure that there's frozen water here in the rings of Saturn. And we do know for sure that there is water vapor in the atmosphere of Saturn. Same for Jupiter, same for all the other giant planets out here. Great question, Tim. Let's do a couple more, Kiara. I feel like this is a good stopping point.
Yeah, they're great questions. So in this vein, Dylan wants to know how planets are made.
Planets are made very, very messily. It is not a careful or pretty process at all. You start off with a nebula, a cloud of gas and dust, just a bunch of junk hanging around in space. And then it starts to compress. Maybe it was knocked by a supernova explosion, or maybe it came close to another cloud. It just got disturbed, so it starts compressing, squeezing down tighter and tighter and tighter. Most of the stuff goes to the core, and let's go ahead and go to the core of our own solar system, the good old sun here. Most of the mass of the solar system is in the sun. Over 99% of the mass gets compressed down to make something like a sun. Then you're left with a ring of material, rocks and ices and gas. And slowly over time, little pebbles can just glue together, and then glue together more, glue together more, glue together more, and you end up with what are called planetesimals. And there can be hundreds or thousands of planetesimals in a young star form or planet forming system. Then the planetesimals collide and start to shake out, and eventually you end up with a collection of planets. We're not 100% sure about the detailed processes that lead to planet formation. As you might imagine, there's a lot of complicated, messy physics, but that's the basic picture. Planets are formed from tiny little things smashing together over the course of millions of years. Great question.
Okay, so Lauren, who's in 7th grade, would like to know why there are storms on other planets.
Ooh. Why are there storms on other planets? This is such a fun question. For this, I'm actually going to go to good old Earth. So we can look at some of the clouds and storms on our own planet. Wow, I need to slow down time. There we go. Weather on the Earth is caused by the fact that the sun only heats one side of our planet at a time. So over here, lots of heat. Over here, super cold. And so because there's these differences, the heat wants to go from the hot place to the cold place. It wants to make everything equal. All of that leads to weather. It leads to the mixing of air and water. It leads to pop-up places with a lot of energy where that energy gets released. We call these storms. This can happen on the Earth. It can happen anywhere. Wherever you get heat on one side and cold on the other, and that thing wants to make everything equal, you get a lot of mixing, you get a lot of weather, you get a lot of storms. Great, great question.
Okay, so Ian, who is 8, would also like to know, why are rocky planets on the inside and gassy planets on the outside of the solar system?
This is such a clever, clever question. Thank you for asking it. Yeah, you may have noticed we have 4 rinky-dink rocky planets in the inner part of the solar system. Then we have the asteroid belt. And then we have 4 giant planets in the outer reaches of the solar system. And the difference is 2 things. 1, ice cannot exist close to the sun. Here where we are on the Earth, our orbit, we are too close for ice. A random block of ice hanging out in space at this orbit will melt because the sun is too bright. You have to go further out. You have to go past the asteroid belt to get some ices. This means that the planets in the outer parts of the solar system, when they were forming, they didn't just have rocks to play with, they also had ice to play with. They had more Lego pieces to put themselves together so they could be bigger. Their cores could be bigger. And then with those bigger cores, they were able to suck up any bits of gas around them, like hydrogen and helium. All that light gas got blown away by the heat of the sun, but could hang out in the outer solar system. The short version is there is simply more stuff in the outer parts of the solar system than the inner parts of the solar system because it's too hot here to maintain all that stuff, all the ice and all the gas. But in the outer solar system, you have a lot more to play with, so you can build a lot bigger planets. One more question before I zoom out to Pluto.
All right. Tristan would like to know if the moons on Saturn sometimes pass through the rings.
Great question. Let's fly out to Saturn. Bye-bye, Earth. Check this out. Where's one of the moons? Let me spot one. Here we go. Here we go. Check it out. Check it out. Check it out. Wow. Does this answer your question? There are moons inside the rings of Saturn. And in fact, there's this very complicated, poorly understood relationship between the moons of Saturn and the rings. The moons, the gravity of the moon shape the rings, guide the rings. We have examples of some of the moons embedded in the rings, creating gaps or closing gaps. Yes, you can sit here on a moon like this one, Prometheus, and hang out inside the rings of Saturn. Not for long, because you're going to get pummeled with like trillions of ice cubes traveling at tens of thousands of miles per hour, but you'll enjoy it while you can. Now, before we run out of time and go over to trivia, and remember, trivia, the game is going to be played with Slido. Go to slido.com on your phone and use the hashtag Sutter, that's capital S, and then normal, UTTER, and you'll get to play along with us on your phone. That's slido.com. But for now, I need to go to everyone's favorite planet, but not a planet, Pluto. Way out here in the distant outskirts of the solar system, we have Pluto. Here we are. Check this out, guys. Check this out. Where's the sun? Where's the sun? Look at that. Look at that. Could you imagine for a moment? I just want everyone, wherever screen you have, can you minimize everything else? Can you take away all your distractions? Focus just on this view of Pluto. Could you imagine living out here? Could you imagine being out here? Standing on the surface of Pluto or in orbit around Pluto, where you are locked in permanent twilight. At high noon, the sun is so tiny and so weak, it's barely more than another star. And so go out tonight, right after sunset, before it gets completely dark, go out and experience that level of light and imagine that's the brightest it will ever get. The nearest objects, major objects to Pluto, are millions and millions and millions of miles away. This is the definition of loneliness out here. we launched a probe out here to check out Pluto, and that's how we got these high resolution maps. The New Horizons mission left Earth in 2006. It traveled at over 36,000 miles per hour, and it took 9 years to reach Pluto. 9 years. And all in all, it spent around 15 minutes near Pluto. It just buzzed by. It took 9 years, and it was spent 15 minutes near the Pluto system. This always blows my mind. There's just these distances, these scales, this vastness. Here we are at the very outskirts of the solar system, where we're practically in interstellar space. All right, yes, you feel the gravity of the sun, but not much else. You certainly don't feel the warmth or the light of the sun, not like how we experience it on the Earth. So if you really want to get away, Pluto is your best bet. Kiara, why don't we spend our last few minutes answering a few more questions?
Okay. There are quite a few good ones.
Yeah, I see lots of questions coming in. That's so cool. Thank you, everyone, for all these awesome questions. And if we have time after trivia, I'll do some more questions.
So I think a great question is one about a new mission called Dragonfly. Dragonfly is scheduled to arrive on Titan in 2034, which is also a laser interferometer space antenna, which will detect gravitational waves from supermassive black holes will launch, just as a fun coincidence. Missions to Titan started in 1979 with Voyager. Why have we been studying Titan for so long? And do you think it's habitable?
Oh my gosh, awesome question. Let me slow down time. So here we are, Titan. Titan is the largest moon of Saturn and is one of the most intriguing places in the solar system, bar none. This is a pretty big moon. It's about the size of our moon. And you can see, look. This is not the surface of Titan. This is the atmosphere of Titan. This is the atmosphere. It has a thick atmosphere. It has an atmosphere thicker than the Earth's. It has an atmosphere second only to Venus itself. What's more, underneath this thick, hazy atmosphere, there are oceans and rivers and streams, but not of water. You see, the temperatures here at Titan, even under those cloud tops, are around negative 240 degrees Fahrenheit. That's a little bit too cold for water, but it's not cold enough for liquid methane. There are seas, there are oceans, there are streams, there is rain of liquid methane. This is actually the only place in the solar system other than the Earth with liquid anything on the surface. Now on Earth, life got its start with liquid water. Could some form of life with some strange, exotic, weird chemistry exist in the methane seas of Titan? We don't know. That's why we're developing missions like the Dragonfly mission, which are a proposed lander, or not quite a lander, a mission to Titan to actually fly around in this thick atmosphere and explore it. What will it find? Who knows? Who knows? I'm excited. I'm curious about Titan. There's something funky going on here.
Awesome. Thanks, Paul. Another question that's come up quite a few times in various different ways is essentially, what other planet or moon could we or should we terraform or colonize?
I'll show you the planet that I think is best suited for terraforming. Here we go.
I totally agree.
Boom. Here's the one. Listen, we already got it. Nature's done the vast majority of the hard work. How about we stop messing the place up for once? It's going to be way easier than trying to terraform anything else. That's for sure. Okay, one more question. One more question.
100% with you. This is the last question, and I think it's a great one. Mark would like to know about the Trappist exoplanets. Maybe you could say what they are, why they're special, why do they even have a special name?
Yeah, this is cool. This is cool. I don't even know if it's in this system. No, I can't fly there. I can't fly to this software. By the way, you should get this for home. It's totally free. You can fly around the whole entire universe. We just did the solar system, but it's not in their database. The Trappist system is Trappist 1 is the name of a red dwarf star. So it's a tiny star, not even half the mass of the sun. But what's remarkable about it is that a couple years ago, we found 7 planets in orbit around that star. That's 7 exoplanets in orbit around the Trappist 1 star. 3 of these planets exist within the habitable zone of that star. That's the region around a star where it's not too cold to freeze all the water and not too hot to boil it all the way. These 3 planets are potentially capable of hosting liquid water. And where there's liquid water, there is the potential for life. So that was just one system. One system had 3 potential homes for life. Now, these planets could be like Mars. These planets could be like Venus. These planets could be a little bit like Earth. Won't know until we study it more. So it is 5 o'clock. Let's switch over to the trivia game. Let's have some fun. Let's kick back, relax with your families. And if we do have time at the end, we will do some more questions, but I'm hungry for some knowledge. So we are collecting people. Look at all these people. Wow. We've got 51 people joined into the quiz right now. All right, who's going to be the champion? We'll give it just a couple more minutes. We wouldn't want someone to just come in late and miss a couple questions. So we want to give people a chance, download the app, type in the hashtag. There you can see the app. There's also a QR code right there on the screen that you can scan with your smartphone or computing device of your choice. Look at all these people. Please don't put a swear word as your name because this is a family-friendly event. Great. Did I just give someone an idea I shouldn't have given? I always do that. Yeah, let's get these. Come on in, folks. Come on in. We've had our tour of the solar system. We've learned that as nasty as the Earth can be, it's the only place that we can call home. Martians are joining us. A little bit of a time lag on there for connection to Mars. That's okay. We'll let you play. We'll let you keep up. Oh, everyone is piling in. Wow. Once I see that counter start to slow down a little bit, once we get out of that exponential growth phase of people joining the quiz, we will start the game. But in the meantime, I'll just sip my drink. This is going to be fun. I should mention that these questions I actually got from a fan of mine. I got these from Cosmologists Without Borders. You can go to cosmologistswithoutborders.org. They gave me these questions to use, and I want to shout out to them. Thank you so much. 93. Do you think we can make it to 100, Kiara? Or maybe we're just going to sit at 93. See, as soon as I called out a number, I knew it was going to.
I think that we can give it maybe 30 more seconds.
Come on, 30 seconds. I know there's 7 people in there.
I have faith.
I know you're a very, very confident, optimistic person.
Indeed.
Yep, and I bet that gets you in trouble because it looks like we're sticking at 93.
All right.
So we shouldn't have said anything.
Take off.
We shouldn't have said. Okay, 95. We can do it. We can do it. This
I'm a
is, I don't
compromising.
know why I'm so pumped about this. This is the most exciting thing that's happened to me all day.
Me too. But yeah. All right. I think I'm gonna have to call it. Let's get
Okay, let's do it. We want to get to the game. We want to get to the game. Question number 1. Here we go. Which planet in our solar system would float if you placed in water? Is it Mercury? Is it Saturn? Is it Neptune? Get your answers in. Now we've got 95 people playing. So we're going to see, we're going to let that counter go up, but we're not. And hey, don't look this up on Wikipedia. Be honest here, folks. Okay, I'm watching you. I'm watching you. Besides, you don't have enough time. We're going to keep this moving. We don't got time for you to start float water. Look up the result within Google spell check and everything. No, we ain't going to wait for you. 5, 4, 3, 2, 1. Reveal the answer. The correct, oh wow, look at that distribution of votes. The correct answer is Saturn. That's right, Saturn isn't very dense. It's not very dense. If you had a big enough bathtub, you could float Saturn. But don't let Saturn take a bath in your bathtub. You know why? Because it'll leave rings. Just go to the next question. The sun contains what proportion of the mass of our entire solar system? That includes the 8 planets, the dwarf planets, the moons, the dust, the gas, the space rocks, the comets, the asteroids. Is it 1%? Is it 50%? Is it 99.8%? Get your votes in. We're going to do a countdown in 10, 9, 8, 7, 6, etc., 2, 1. Lock it in. Wow, I think you guys are smart. You guys are smart. Show, reveal the answer. Good job. That's right. Most of the stuff in the solar system is in the sun. And you thought you were all that in a bag of chips. Next question. What is the process that enables the sun to generate radiant energy, as in heat and light? What keeps you warm on a sunny day? Is it called aurora borealis? Is it called nuclear fusion? Is it called Cherenkov radiation? By the way, that last term is a real word. That is not a Star Trek technobabble word. It's an actual real science word. All right, get your vote. What was that, Kiara?
One of my favorites.
It's Cherenkov radiation. I like Bremsstrahlung a little bit better. It has that edge because it has that deep German like oomph to it. But enough nerdy jokes. Reveal the poll. That's right. A bunch of smarty pants in this audience. That is correct. Nuclear fusion. Now remember, there is going to be a leaderboard showing the top 5 people playing this game. You're not going to win any prizes except I'm going to give you a virtual high five. Next question. Which planet in our solar system has the hottest average surface temperature? That's temperature on the surface. Mercury, Venus, or Earth? I would play the Jeopardy theme song, but it has been copyrighted. And so you will just have to imagine it playing in your head as you put your answers in. There we go. Looks like we're getting around 80 people. Once we hit around 80, 85 people, we can close the poll. Again, I'm not leaving you time to look this up online. Go ahead and move on. That's right. It's Venus. Because of all those thick cloud layers, it is the hottest surface temperature in the solar system. Moving on. Question number 5. How many planets in our solar system have rings? 1, 2, or 4? You know it's at least 1, don't you? We saw those impressive rings from Saturn. Think about it. Think about it. Let me see. The Earth definitely doesn't have rings. Mercury and Venus. We're doing do some subtraction and carry the 2. What do you think it's going to be? I see answers coming in a little bit slower than usual. You got to think about this. You got to think about this, don't you? All right. We've hit 85. Let's go ahead and close it. Let's see what you guys guessed. 1, 2, or 4. Show the answer. Boom. All 4 of the giant planets in our solar system do have rings. They're very faint, they're very tiny, but they're not non-existent. They exist. Next question. NASA's Deep Impact spacecraft traveled almost 500 million kilometers, or 1/3 of a billion miles, at 40 times faster than a speeding bullet to catch up to a comet, then released an impactor probe with no explosives that gouged a 150-meter crater out of the comet. Is this a true story, or am I just making things up on the spot? You tell me. And don't Google NASA Deep Impact. Also, don't Google Deep Impact. That's a movie. It's just different thing. Or maybe tonight, let's make movie night tonight be Armageddon with Bruce Willis. Did you like that movie, Kiara?
I didn't want to miss a thing.
Don't want to miss a thing. That's right. We're getting a little loopy here in the last section of this webinar. All right, we've got over 80 votes put in. Let's see what you guys got. I was telling the truth. It's a real thing. Guys, reality is stranger than fiction. We do stuff in space that would blow your mind, okay? This is one of them. Next question. Mercury and Venus don't have any moons. Earth has 1. Mars has 2. How many moons does Jupiter have? Now, I talked about the moons of Saturn, but not the moons of Jupiter. So how many you think are orbiting the biggest planet in our solar system? I'll give you a hint. I did say that Saturn has over 80 moons and has the most moons of any planet. That doesn't really help you at all, since all of these numbers are less than 80. So what do you think it is? And you should also note that moon, the word moon, does not have a strict scientific definition. If you orbit a planet, and you are somewhat kind of sort of large, you are called a moon. This is a tough one for people. I feel people are like getting a little nervous. They thought it was all easy, like, ooh, what's the hottest planet? Ooh, we got easy. Now we're getting a little tough. But we've hit over 80. Let's see what the results are. And you are correct. The majority of used people's over 60 moons. There are a lot of moons in Jupiter. Let's go to question number 8. What is the largest moon in our solar system? The moon of Jupiter, known as Ganymede, the moon of Saturn, known as Titan, or the moon of Earth, known as Moon? What do you think it is? I did mention the size of Saturn's moon. Or is it going to be Ganymede? And I know a good chunk of people are saying, what's a Ganymede? I don't know. What is it going to be? What do you think, Kiara?
I don't know. I'm a black hole kind of person myself.
Yep. That's fair. These are all just like weird rocky floaty bits in the universe.
Yeah. I mean, I do like, large objects like black holes, but these ones, I think if I had to choose, I would probably pick Ganymede.
All right, let's see. Are you playing, Kiara?
Nope.
Okay. Ganymede is the largest moon in our solar system. Titan is rather large, but not big enough to take the top spot. Very decisive amongst our audience. Next question. A person that weighs 150 pounds on Earth would weigh how much on the moon? Now, you know the moon is smaller than the Earth. Ooh, it's about 1/4 of the radius of the Earth. It's very, very small. So you're definitely going to be lighter. We also seen those videos of astronauts like doing that weird bunny hop thing. So they're definitely lighter. Do they weigh 25 pounds, 60 pounds? Oh, it's not 300 pounds. Don't worry, I already revealed that one. It's a guess here. Is it just like half? Is it way light? This is a tough one. This is a tough one. Don't worry if you're feeling like you have to guess. But we got over 80 responses in, so let's go ahead and reveal the poll. All right, and the correct answer is 25 pounds. Imagine if you just weighed 25 pounds. That's why those astronauts are doing all those bunny hoppy things. Next question. A person that weighs 150 pounds, same person, or different person, but same weight, on Earth would weigh how much on Jupiter, the largest planet in the solar system? And this is pretending that you could stand on the topmost layer of the atmosphere, that you didn't sink down and get crushed into oblivion in the hot, dense core, okay? So you're at the cloud tops, you're hanging out. How much do you feel like you weigh? It's the biggest planet, so it's probably going to be a little bit more than what you weigh now. Is it going to be twice? Is it going to be 3 times? Don't worry if you're guessing. I wouldn't expect you to know this off the top of my head. I don't think I would know it off the top of my head. But I get to be like Alex Trebek and pretend I know all the answers in advance. Let's reveal the poll. What did you guys think? Ooh, a lot of discussion between 380 and 500 pounds. What's the answer? 380 pounds. Here's the tricky thing. Jupiter is so much more massive than the Earth, right? But it's also bigger. So when you're at those cloud tops, when you're at the top, you're very, very, very far away from the center of Jupiter. And that's going to lower your feeling of gravity. Next question. Person that weighs, I know you're really liking these questions, aren't you? 150 pounds on Earth would weigh how much on a large neutron star? Now, we did not talk about neutron stars today. Neutron stars are amongst the most dense objects in the entire universe. They are crazy dense. They are, imagine taking several suns worth of material and cramming it down to no bigger than a city neighborhood. That is dense. That's a lot of gravity. That's why all these numbers are very, very large. But just how large are we gonna go? People are nervous. What was that, Kiara?
That's heavy.
That's heavy. That's heavy. And I can see people are a little bit nervous. They're like, I'm not exactly sure. I don't want to go to a neutron star to find out, but let's reveal the poll. How'd we do? And the correct answer, that's right. That's right. 21 trillion pounds. A spoonful of neutron star material would weigh more than the Great Pyramids. Boom. Crazy, right? Next question. We're halfway through, folks. We got this. Beauty contest. Now, I know that this is an opinion question, and I know we're playing trivia to win. I want you to pick what you think my favorite planet is, okay? Based on today's webinar. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We're going to put Pluto in there just because we have a soft spot for Pluto, even though it's not technically a planet. What do you think my favorite planet is? Go ahead and reveal the poll now a little bit early. Nobody picked Mercury. Sorry, Mercury. Ouch. And, well, but people are still... Is it locked? So when we go to the polling result, is it locked? Can people no longer put in? Did I break it? Did I break the polling thing? That's okay. Reveal the correct answer. My answer. It's Earth. I live here. I've got a home here and everything. Of course, it's my favorite planet. Let's move on. And I won't cut out early again. I thought we could see it shift around as people voted. What's the largest planet in our solar system? Come on, folks. You got this. You got this. I know you got this. I know you got this. Don't disappoint me. Don't disappoint me. Okay, we got 80 answers in. Let's see the results. Boom, Jupiter. There it is. I don't know which one of you smart Alex picked Earth, but I see you. I see you. Next question. What is the largest rocky planet in our solar system? Ooh, you were feeling all high and mighty after that question. Now you don't know which one of the rocky planets. The 4 rocky planets: Mercury, Venus, Earth, and Mars. Definitely not Mercury, because apparently nobody cares about Mercury. But Venus, Earth, and Mars, which one is the biggest? Get your votes in. Okay, we've got over 80 responses, so let's see the results. Nice job, people. Nice job. The answer is Earth. Good, Oler. We got something. We got something. We're the biggest rocky planet in the solar system, eh? We also have one of the biggest moons in the solar system. Yay, Earth. We also have like liquid water and life and all blah, blah, blah. Next question. Smallest planet. Hint. It's the one we have all decided by unanimous vote we do not care about at all in this webinar. Not just me. And that's just not me projecting onto you. That is me giving my opinion and all of you agreeing with me spontaneously. What is the smallest planet in our solar system? Let's see the results. That's right. Mercury. Good job. Moving on. How long does it take for the Earth to rotate once around its axis? That's spin around like a top once. As you watch the sunset tonight, I want you to think about this question. Bring some answers in. Parents, if you're letting your kids vote, just don't try to overrule them. Like, let them vote. Let their voices be heard. We've got over 80 results in, so let's see the results. That's right. It is 1 day. To rotate on its axis, that is 1 day. Move on to the next question. How long does it take for the Earth to orbit once around the sun? It's definitely not a day, because that was the last question. Now it's the rotation on its axis, but now it's how long does it take to orbit around the sun? Orbit around the sun. Let's see the results. That's right. That is the definition of a year. Every time you celebrate your birthday, you have gone around the sun 1 time. Next question. We're getting to near the end. Don't lose stamina. Don't lose stamina. Our entire solar system is traveling around the Milky Way galaxy at a great and terrible speed of 828,000 kilometers per hour. That's fast, in case you wondered. How long does it take to complete 1 full orbit? That's right. Our sun is orbiting the center of the Milky Way galaxy. How long does it take to make 1 orbit? Is it 10,000 years? Is it 50 million years? Is it 220 million years? This is a very, very good question to get you guys thinking of matters truly interstellar. Like, this is the big stuff. Let's reveal the results. Big split here between 50 and 220. Let's go. That's right. 220 million years for the sun to orbit the Milky Way galaxy once. That's just a really long time. No further commentary needed. Next question. Aside from life on Earth, do you think life exists anywhere else in the solar system? Now, again, this is an opinion question, but to score points, you must agree with me. And I mean now, do I, Paul Sutter, your host, think that life exists anywhere else in our solar system? What do you think? Try to read my mind. I'm thinking really hard. I know telepathy is not a thing, but I'm gonna point at my skull a lot. All right, let's see the results. That's fair. That's fair. What do I think? I actually do think there is life somewhere else in the solar system. Not intelligent life. I think there's a few like space microbes or something floating around. There's a lot of liquid water in some surprising places. I didn't get to it in the presentation, but there's some hints of that. What do you think, Kiara? Do you think there's life in the solar system?
Oh yeah. I mean, I think it
There you
would
go.
be really
Oh
hard
yeah.
for there to not be life somewhere in the solar system.
Somewhere. There's a lot of options. There's a lot of real estate. Next question. This is again, what do you think of Paul Sutter? Aside from life on Earth, because life established, it exists. Where will we first find life in our solar system? So here's some candidates. Nowhere. Mercury, Venus, Mars, the moon of Jupiter called Europa, the moon of Saturn called Titan, or the moon of Saturn called Enceladus. I haven't told you about Europa and Enceladus. They have icy crust, but underneath them, they do have world-spanning liquid water oceans underneath their icy crust. So there's liquid water on Europa and Enceladus. There's liquid methane on Titan. There is definitely water on Mars. Maybe not liquid. What do you think? What do you think, Yara?
My money's on Europa.
Your money, that's a good bet. That's a good bet. Let's see what our audience thought. Ooh, split between Mars, Europa, Titan, and Enceladus. A few holdouts on thinking there's not life in the solar system. What did I think?
Oh.
Yep. My money's on Europa too. It's not a lot of money, just like $20, but
Yeah.
that's where my money is. It's on
I don't
Europa.
have a lot of money either. Yeah.
Next question. We've just got 3 more, folks. When 2 galaxies containing about 200 billion stars each merge together, how many stars are likely to crash into each other? Imagine 2 massive galaxies colliding and merging. What happens to their individual stars? Do a bunch of them crash into each other? Do some of them, or do none of them? Think about it. I want you to think about interstellar distances, about how even when we're just at Pluto, how far away and lonely the sun seemed, and apply that kind of thinking to an entire galaxy and what would happen. By the way, we are going to experience this firsthand. Our Milky Way galaxy is on a collision course with the Andromeda galaxy, our nearest neighbor. If you're alive about 5 billion years from now, you'll get to see what happens. And what did the audience think? Big split here. That's fair. And what is the correct answer? Stars don't crash into each other. You know why they call it space? Because there's a lot of it. Next question. Second to last, what is the ultimate fate of our universe? Is it the big crunch? Is it the big rip? Is it the big chill? Or is it the vacuum decay? And I'm going to preface this. What is this answer based on our current understanding of the contents of the universe and the evolution of the universe? The answer might change like 10 years from now, but right now, as of April 17th, 2020, what do we think is the ultimate fate of the universe? Keep thinking big crunch is it's just going to crunch all back together again. Big rip is it's going to tear itself apart in a fury of vacuum energy. Big chill is just going to hang out and cool off slowly. Or vacuum decay, it will transform into something else entirely. Fun question to set the mood on a Friday evening, the ultimate fate of our universe. What did the audience think? Lots of big chill, but fair representation amongst the other questions. What is the correct answer? That's right. Another name for the big chill is the heat death of the universe. Makes for a great bedtime story for your kids tonight. Very last question of the night. Now this is according what you think is going on in my brain. If you're a fan of mine, you already know the answer. If you're not, you're just gonna have to guess based on my attitude this evening. Do we live in a multiverse or a universe? Is it our universe is the one and only universe, or there are many parallel universes existing simultaneously? What do you think, Kiara?
I don't think that it would be possible to travel between the multiverses, so I'm not sure that there's a meaningful answer to that question.
That is fair. That is fair. It is impossible to travel between the multiverses, so it doesn't matter because it's outside of our observable universe.
But I loved sliders when I was a kid.
I love sliders
And
too.
sliders would be
Yeah.
awesome. So I kind
We
of
gotta go, and then
hope
and they jump in, and they're like,
exactly.
"Oh no, the Nazis are in charge now!" And like, "Oh, we
So
gotta get back."
I think it would be awesome, but I think it's kind of like superluminal particles, right? Like it doesn't
Hmm.
matter.
It's
But
fun, but
I would like it to be true.
okay. What do I think? Well, let's see what the audience thought. Ooh, lots of people thinking we live in a multiverse. Unfortunately, you are wrong. And even though this is purely an opinion, my opinion is the correct one. All right. Let's see. Drum roll, please. Let's see our big results. Who won? Tom, 22 out of 23, and also the fastest time on the board in answering questions, followed by Vic, Nancy Graziano, Andy, and Mike Murray. Look at those. Tom, and the hardest question was, do we live in a universe or multiverse? Tom, here is your virtual high five. Good job, Tom, and to all the winners. And thank you, everyone. I hope you had fun this evening. I certainly did. I hope you enjoyed this tour of the solar system. I hope you got to learn a little bit about our home planet and the rest of the planets in our solar system. I'd like to give a huge thanks to Kiara for hosting tonight, for the Simons Foundation for putting all this together, and a giant thanks to all of you for showing up. Hope you're a little bit entertained, and I'll catch you around. Thank you so much, everyone. Have a great
All
evening.
right, everyone, join me in thanking Paul for doing an excellent job, and we'll have the name of the software to you if you're interested in, and in Paul's contact details on the last slide that we're about to put up. Here we go. And don't forget to check out Paul's website, and you can follow Paul on Twitter. So the next Simons Foundation Presents webinar is Climate Change, What's New, with Catherine Hayhoe, and that will be on Friday, May 15th at 4 p.m. So thank you, everyone, so much for coming, and thanks again, Paul, for doing a great job.